Damn. Yeah.
Everyone, I'm Chai-Feng. This video will go to Form 4 Chapter 7, Graph of Motions. In this chapter, we will learn two types of graph, distance time graph and speed time graph. Okay, so let's start the lesson now. Let's go. Okay, before I start, let's refresh back something you learned in Form 2. In Form 2, you learned about this triangle, right? And we will separate it into three parts. Okay, so first which represent D which is the distance, and here represent the S which is the speed, and here represent T, and T stand for time. If you want to find the distance, you need to speed times time. If you want to find the speed, you need to distance divided by time. If you want to find the time, you need to distance divided by speed. Okay, from here you can see that when you find the gradient of the distance time graph, it means that it's a speed. We can also say that it is rate of change of distance with respect to time. And next slide, I'm going to share with you how to draw the distance time graph. In example 1, we will learn how to draw a distance time graph. Okay, so let's start. The motion of a particle for a certain period is represented by S is equal to 3t plus 2, where S is the distance in cm and t is the time in seconds. Draw a distance time graph to represent the motion of the particle for a period of 5 seconds. Okay, so let's start solving this question. So first, let's draw a table first for your graph. Okay, since this is 5 seconds, so let's write down the time first from 0 until 5. 1, 2, 3, 4, 5. How do we find the distance? We just need to substitute this 0 inside this equation. So S is equal to, so we just need to sub 0 inside. Okay, 0 plus 2. So what we will get 2. From here we can get is 2. Yeah, we just repeat the process, and after that we will find out the answer of the distance. Yeah, so it's 2, 5, 8, 11, 14, and 17. Okay, now I already draw the x-axis and the y-axis. So now we have to label the x-axis with the time in the second, and in y-axis this will be the distance in cm. Now I'm going to label the value of the graph first. Okay, so from here time, okay, since it is 0, right? 0, here is 1, okay, 2, 3, 4, and 5. Okay, so now here is distance 5, okay, 10, 15, and the last one 20. Okay, after labeling the graph, let's start to plot the graph. Okay, so since this is 0 with the 2, right? So I block here x, and it is 1 with the 5. Okay, so 2 with the 8. Okay, 3 with the 11. Okay, 4 with the 14. And 5 with the 17. Okay, after plot the graph, we need to use the ruler to draw the graph. Since I don't have ruler, so I just use my free hand. But you guys remember need to use the ruler. Okay, need to connect all the point. So this is my graph. And don't forget everyone, must remember to write the equation of the graph. Okay, so I will label it as S is equal to 3t plus 2. Yeah. Before we go to example 2, let me share with you more about the distance time graph. Okay, this is one of the example, the distance time graph. So first, we assume this represented by a ball. You can see from O to A, the gradient is positive. So it means that the ball will move to the right hand side. So how about from A to B? Gradient is 0. It means that the ball is no move, just stay there. How about from B to C? Yeah, here is also positive. Okay, and the balls also will move to the right hand side. Okay, so what do you think you will see in this graph? Okay, let me draw for you. Okay, let's say here is the ball. Yeah, assuming is a ball. Okay, O. Okay, so first from O to A, since the gradient is positive, so the ball will move to the right hand side. So the ball from here to here. Okay, since A and B the gradient is 0, it means the ball just stationary. It will just stay there. So here we also can call it as the B. After that, from B to C, the gradient is a positive. So the ball will move to the right hand side also. Yeah, so here is C. Yeah, so this is how the graph look like, how the ball move. One more example with distance time graph. So first we can see that from O to P, the gradient is positive. So the ball will move to the right hand side. So P to Q, yeah, is the gradient is 0. Since it's 0, so it's stationary. The ball will just stay there. And from Q to R, yeah, we can see the different. The gradient is negative. So negative means the ball will move to the left hand side. So this is the difference between the example of just now. And now I will show you guys what's the movement of the ball look like. Okay, so we assume the ball is here. First, from O to P is positive, so it means the balls will move to the right hand side. So here is P, go there. Okay, the ball is here. Since it's P to Q, the gradient is 0. It means the stationary, so the ball will stay there. Next, which is from Q to R, gradient is negative, so the ball will move to the left hand side. From the graph, we can see the distance from S go to the 0, so he will go back at the previous. So this is the movement of the graph. So this is how the movement of the graph looks like. Okay, so the last thing you have to know is the average speed of the whole journey. So the formula of the average speed is equal to total distance divided by total times. Okay, let me show you how I calculate the average speed of the whole journey. From here we can see that we put km first, and here we put that second. From here we can see that from 0 second until 5 second, he start from 0 km until 20 km. So the total distance of this graph is 20 km. We need to divide by the total time. The total time is 5 seconds. So the average speed of this graph is 20 divided by 5, so it means it's equal to 4 km per second. This is how I find out the average speed. And next, I'm going to show you the example questions of the distance time graph. Okay, let's go to the example 2. and this is the distance time graph. Okay, the distance time graph shows the motion of a car for a period of 4.5 hours. So first we need to determine the duration when the car is stationary. Stationary means when the gradient is equal to 0. Okay, so from here we can see that the gradient becomes 0 when the time is 2 until 3 hours. Okay, so we just 3 minus with 2. So the stationary period is equal to 1 hours. Next, A2. The speed in km per hour of the car in the first hour. Means you need to find the speed the first hour, then means we need to find the gradient. So how to find the gradients? Just take the 150 divide with 2 hour, so we'll get 75 km per hour. B. Describe the motion of the car for the last 90 minutes. Need to find out the gradient of the last 90 minutes. So how do we find? We need to find the speed of car, right? We just find out the value of this part, which means 270 km minus with 150 km divide with 90 minutes, which means 1.5 hour. So we get the 80 km per hour. So the conclusion, which is the car travels for 120 km with a speed of 80 km per hour in the last 90 minutes. So that's all for the example 2. And next I will go to the example 3. Okay, let's move on to the example 3. Okay, Zabida wants to visit her friends in Muar. The distance time graph shows her journey by car from Segamet to Muar, passing through Tangkat. So it means that he start from Segamet, he will passing through the Tangkat, and finally he will reach Muar. Okay, so question A. Calculate the average speed in km per hour of Zabida's journey from Segamet to Muar. Okay, so first we need to find out the average speed. So what is the formula of average speed? Which is total distance divided by total time. So how to find the total distance? We can find out it here is 80. What's the total time? Is 1.5. Just 80 divided by 1.5, we get 53 with 1 over 3. B. If the rate of change in distance of the car from Segamet to Tangkat is 50 km per hour, calculate the distance in km between Tangkat and Muar. For this question, we know that from O to Tangkat, the average speed is 50 km per hour. So we need to find out the S so that we can 80 minus with S, we will get the total distance between Tangkat and the Muar. Okay, so first, the total distance, which means is equal to average speed times total time. Okay, from here you can see, just move the total time to left hand side, we will divide become times. So total distance is equal to average speed times total time, which is the 50 km per hour, and the total time is 1 hour. So we will get S is equal to 50 km. So how do we find the distance between the Tangkat and Muar? We just need to 80 minus with 50, so we will get 30 km. Okay, next question C. Describe the motion of the car from Segamat to Muar. Okay, let's see how to do it. Okay, so the answer is the car moves from a distance of 80 km in 1.5 hours with an average speed of 53 with 1 over 3 km per hour. So that is the answer. Okay, now let's go to the second type of graph that you have to learn in this chapter, which is speed time graph. Okay, gradient of the speed time graph represent by acceleration and also represent the rate of change of speed with respect to time. Okay, let's go to the example 4 and I will show you how to draw the speed time graph. Okay, so draw the speed time graph by constructing a speed time table to represent v is equal to 5 minus t, where v is the speed in meter per second and t is the time in second of 0, and 0 less than or equal to t or less than or equal to 5. Since the duration is 0 until to write out the time, okay, so the time is 0, 1, 2, 3, 4, 5. How do we find the speed? Right, we just need to, same like previous, the distance time graph, we just need to sub the time inside this equation. Okay, so v is equal to 5 minus weight the t. So we do sub like this 0. Yeah, so from here we can get 5. Another like same step, we just repeat the step by step. So we will get 5, 4, 3, 2, 1, and 0. Now I have already drawn the x-axis and the y-axis. I also labeled it already. So y-axis represent the speed, which is meter in second, and x-axis represent the time in second. I'm going to label the value of the graph. Okay, so since the time is from 0 until 5, so we just need to label from 0 until 5 only. 1, 2, 3, 4, and 5. Okay, also same. Since speed, the biggest value is 5. So I think we just need to scale it 1, 2, 3, 4, and 5. After we label all the value, so we need to plot the graph. When the time is 0, the speed is equal to 5. Okay, when the time is 1, the speed is equal to 4. When the time is 2, the speed is equal to 3. When the time is 3, the speed is equal to 2. So when the time is 4, so the speed will equal to 1. Last, when the time is 5, it will become 0 speed. So do remember, must use the ruler to connect all the block. Since I don't have the ruler, right, so I just freehand. But you guys remember, need to use the ruler, yeah. Okay, now I connect all the block first. Okay, so this is my graph. Don't forget, everyone must remember to write the equation of the graph. So I will label it with v is equal to 5 minus t. Yeah, so this is how I draw the speed time graph. Okay, another things that is very important that you guys need to know in speed time graph, which is the area under the graph actually is the distance travel. So means all of here is the total distance lah. Okay, so let's move on to example 5. So the speed time graph shows the speed of Mrs. Liu's car for a period of 36 minutes. Calculate the total distance in km traveled by Mr. Liu's car for the period of 36 minutes. We need to find the total distance, which means we need to calculate the area under the graph. Okay, so as we know, we got 3 parts we need to find out, which means A part, B part, and the C part. So here is for A lah. Here is for A, B, and C. A, B, C. Okay, so the formula for the triangle is 1 over 2 times base times height. For trapezium, the formula is 1 over 2 times height times width A plus B. So after calculate, we will get 30.27 km. Okay, let's move on to question B. So first, find the average speed in km per hour of Mrs. Liu's car for the period of 36 minutes. Average speed, which means the previous slide that we learned. So the formula of the average speed, which is total distance divided by total time. Total distance we find out, which is 30.27 km. And the time, because we need to change from minutes to hours, so we need to 36 divided by 60. So the final answer that we get, which is 50.45 km per hours. Okay, now let me show you what are the positive and negative stand for in speed time graph. When the gradient is positive, that means the particle is acceleration. When the speed time graph gradient is 0, that means the particle is in uniform speed. And how about a negative gradient? It means the particle is deceleration, which means the particle is slowing down. Okay, let's move on to example 6. The speed time graph shows the motion of one Salinas car for a period of 15 seconds. Question A. Calculate the rate of change of speed in m per second for the first 5 seconds. Okay, so how to find the rate of change of speed? Okay, the formula to find the rate of change of speed, which is the change of speed divided by the change in time. Okay, so first we need to 40 minus with 20 divide with 5 minus with 0. So the answer we will get is 4 meter per second. Okay, so next question B. Describe the motion of the car for the second 5 seconds. That means we need to describe the motion at this this here. So how do we describe? Okay, so the car moves at the uniform speed of 40 meter per second for the period of 5 seconds. Why it is uniform speed? Because the gradient from here is 0. So it means that it is uniform speed. Okay, next we need to calculate the total distance in meter travel in the period of 15 seconds, which means that we need to find out the area under the graph. Total distance traveled is equal to area under the graph, which means 1 over 2 times 5. So this is how the calculate going on. So the final answer, which is 600 meter. Okay, so now let's move on to the last example of this chapter, which is example 7. The speed time graph shows the motion of a car for a period of 14 seconds. Calculate the average speed in meter per second for the first 6 seconds. Okay, before we find the average speed, we need to know that average speed formula is equal to total distance divided by total time. So before that, we need to find out the total distance. Here is the answer. So after that, we find out the total distance is 50 meter divided by 6 seconds. So the final answer that we get is 25 over 3. Okay, now let's move on to question B. Calculate the value of t if the distance traveled by the car for the first 4 seconds is half the distance traveled at the uniform speed. It means that the area of here is 1 over 2 of this. So how do we calculate it? So we need to write down the formula of area of trapezium is equal to 1 over 2 area of rectangle. After that, we can find out the final answer. T is equal to 10. Okay, next question C. Calculate the value of V if the acceleration for the last 2 seconds is 3.5 meter per second. We all know that acceleration is equal to change of speed divided by change of time. So we need to know the difference between the time. So V minus with 10 divide 14 minus 10 is equal to 3.5. After that, we can know that the final answer of V is equal to 24. Yeah, that's all for this video. Hope you all guys like it. Do remember like, share, and subscribe my YouTube channel. Bye.